So we're going to talk about spanning tree, and in this video, the specific aspect of electing a root switch. So before we get into that, let's first just kind of talk real basically at what is the purpose of spanning tree. Spanning tree's purpose really is to prevent loops in a redundant layer 2 topology. You know, if we look at a standard topology here, this is our topology, we have all these links, and these are all layer 2 links, and we have this nice redundancy, so we have multiple links, we can survive failures, but if every single one of these links was forwarding, we would start to have packets looping around, broadcast packets, unknown unicast packets, just flipping around through our network. Eventually the whole thing blows up. So it's spanning tree's job to dynamically block certain ports so that between any 2 points in the network, there is one and only one active path to, between those 2 points. And as long as we have that, we have what's referred to as a loop-free topology. So that's spanning tree's main job, create a loop-free layer 2 topology, as well as to then dynamically react to changes in the network. So if a switch link does go down, maybe that was a forwarding link, okay, now we need to bring another link into a forwarding state to compensate for changes in the network. So it's dynamic in nature, it adapts to changing conditions, but we only want to have one loop-free path, one path between any 2 points in the network. And so in order to create this loop-free topology, the first thing that really has to happen in spanning tree is we need to define a root switch. Now, what is a root switch? A root switch really is the center of the universe for designing this loop-free topology. We figure out who the root is, and then we just sort of branch out this loop-free topology from there. So that's really the first step. And so how do we elect or figure out who the root switch is? Well, it's through an election, and it's through something called the bridge ID. So what's going to happen in our spanning tree topology here is on every layer 2 link, spanning tree is sending out these packets called BPDUs. So we have BPDUs, which are bridge protocol data units, and we're sending these packets out by default every 2 seconds. So every 2 seconds, we shoot out these BPDUs, and inside the BPDU is some different pieces of information. One of those things that's in the BPDU is the bridge ID. And each switch has a bridge ID. And this bridge ID is composed of 2 parts. The first part is a priority value. And then after the priority is the MAC address, the burned in MAC address of that switch. And every switch has a unique MAC address, so this MAC will be different on every switch. So it just concatenates those 2 things. So if it was, a priority of 16.384, MAC address was, 001122334455, it just creates this long string, essentially. It would be formatted a little different. This is in decimal, this is in hex, sorry about that. But you get the idea. It's the priority followed by the MAC address, and that is the bridge ID. And one thing to keep in mind with spanning tree, lower is always better. Lower everything. So who becomes the root is the person who has the lowest bridge ID. And ultimately, we control this by having one switch have the lowest priority. Since the priority is at the front, it's the most significant part of the bridge ID. And so we control the most significant part, and then really the MAC address becomes a tiebreaker in case 2 switches had the same priority, which by default, every switch uses the same priority across the board. So really, fresh out of the box, you start configuring these things. Whatever switch just happens to have the lowest MAC address becomes the root. And usually it's not the switch that you want it to be, because there's usually way more access layer switches than there are distribution layer switches, and you want it to be a distribution layer switch for sure. So it's going to be fairly random based off of the MAC address by default, but we're not going to leave things up to random. So we're going to control it using the priority. And again, lower is always better when it comes to things in spanning tree. So the lower the priority, the better chance it is it's going to be elected the root switch. So let's just kind of look at a cut down version of our topology here. Something I can draw over and not worry about it. Okay, so we have switch 1, 2, 3, 4, and this is WLC 3. Let's say that we want to make switch to our root. This is who we want to be our root. So really all we're going to do is we just want to make sure that as we configure priorities, switch 2 has the lowest priority. And then as we send out these BPDUs across, everyone's going to realize, okay, this is the root, and then everyone will defer to that. So let's go ahead and look at our switches and just see where we're at by default here. So some of the commands that we're going to look at, show spanning tree is pretty much what we start. We can see a lot of different things with spanning tree. We're not going to have to worry about it. So I'll show you the few commands that you really need to look at. And one of them is going to be show spanning tree. And oftentimes with spanning tree, we look at it at a VLAN at a time. Historically, we've really run just plain PVST, per VLAN spanning tree, in our lab, technically PVST plus. We really haven't gotten into things like rapid spanning tree, absolutely never gotten into anything like multiple spanning tree. So I would usually assume we're just talking PVST. And what that means is we have a separate spanning tree instance running for every single VLAN. So oftentimes we have to look at things a VLAN at a time. So let's just pick a VLAN, I'll say VLAN 10. Show spanning tree VLAN 10. So what this is going to show me is a few things. Down below we see every single interface that VLAN 10 has been configured on. And really these are pretty much all my trunks. All my trunks currently have VLAN 10 allowed on them, and so I can see that. And then up above we see information. Under the bridge ID section, this is information about this switch, bridge switch. Consider a switch a bridge for our purposes here. So we see on this switch, the priority for VLAN 10 is 32,778. And our burned in MAC address for this switch is this MAC address right here. We're sending hellos every 2 seconds, sweet. And then up here we have information about the root switch, which may or may not be this switch. And in this case, it's actually not, because we can see that the MAC address of the root switch is different than the MAC address of this switch, which means this switch is not the root for this VLAN. So how do we figure out who is the root without just going to every single switch and running this command? Well, we'll just go to any switch to begin with. And what we can see is that, well, the root is probably in the direction of whatever is plugged into gig 224, which is switch 4 on here. And we can even see down here too that gig 224, that's the root port, which we'll talk about in a subsequent video here. So let's go ahead and jump over to switch 4. Show spanning tree VLAN 10. Now we just happen to see here's the bridge ID information for here. Here's this switch's priority. Here's this switch's MAC address. And it just happens to be the same MAC address. And lo and behold, it even says this switch is the root. This bridge is the root here. So we know that Cat4 is the root for VLAN 10. And most likely, everything being default config, it's the root for every single VLAN. And maybe that's what you wanted. Maybe if they said switch 4 should be the root switch for every single VLAN, how can you verify that without having to run this command 20 times for all 20 VLANs or whatever it is? Here's another command that I really like for verifying the root switch. Show spanning tree root port. If this switch is the root, this is what you'll see. On VLAN 1, it's the root. VLAN 2, it's the root. If you ran this on a switch that was not the root, go back up to switch 1 again, show spanning tree root port, you would just see which port is the root port. And really all I look for here is, I don't care what the port is, I just want to see, is this the root or not? Here I know this is not the root switch on any VLAN. Here I see this is the root switch of every VLAN. And so it's just a real quick verification. If switch 4 was supposed to be the root for every VLAN, I can see, yes, indeed it is the root switch for every single VLAN, because every single VLAN says this bridge is the root. But we don't want that. We want Cat2 to be our root. So let's jump up to Cat2, and we'll use our priority to configure that. So again, if we look at the priority of the current root, jump up again, Right now it's 32,778. So we just need to get lower than that. Most likely this is our priority on Cat2. Show spanning tree VLAN 10. Yep, everything's the same priority by default. So let's go ahead and just drop it lower. That should make the switch the root. Every command starts with the word spanning tree. And on here, what we need to do is we want to specify what VLAN are we configuring, because we can configure one VLAN at a time. If they just said that only make switch to the root VLAN, or the root switch for VLAN 10, I could just say, okay, VLAN 10 priority, and we have a range of 0 through 61,440 in increments of 4,096. My suggestion, if you want it to be the root, just say 0. It's the lowest it can never be. It gives it the highest chance of being the root. But I only did this for VLAN 10. So if I look at show span VLAN 10, hey, this switch is the root. But it won't be the root for anything else. You know, VLAN 11, nope, it's not the root. If I do that show a spanning tree root port command, I see only one VLAN, and I actually have the root on. Oftentimes, it'll be probably one of two scenarios. They'll either say switch 2 should be the root for every VLAN, in which case you would say spanning tree VLAN 1 through 4094 priority to 0, and now it's the root for every single VLAN. Or then they'll start saying we want different roots for different VLANs, and so they might say, you know, switch 1 is the root for VLANs 1 through 50, switch 2 is the root for 51 through 100. Or switch 1 is the root for all odd VLANs, and switch 2 is the root for all even VLANs, in which case just make sure specify the correct VLANs as you define your priority statements. So now that I've configured it, show spanning tree root port, we see that it's the root for every single VLAN. On switch 4, it should not be the root anymore. So switch 4 understands, yes, Cat2 is the root now. And so that's really the basics of defining who a root is. Just make sure it has the lowest priority, and you should see the results. Now there's a couple things that you want to look out for. Let me go ahead and put you into a scenario that you might see in the lab. So let me edit some trunks here. So int range gig 1, 0, 21 to 22. So I'm going to remove a VLAN from my uplinks on Cat4. Switch port trunk, allowed, VLAN, remove. Let's remove VLAN 10. So now if I look at show spanning tree VLAN 10, it's not on any port, and that's actually not good. So let me get VLAN 10 at least active somewhere. Int gig 102. This is an access port, switch port mode access, switch port access VLAN 10. Just to get something so spanning tree actually can be up. Show spanning tree VLAN 10. Okay. So now let's rerun this verification. Show span root port. Okay, Cat2 still says that it's the root. It's supposed to be the root, right? Let's look at Cat4. Show spanning tree root port. It's the root for VLAN 10. How is that possible? Two switches say that they're the root for the same VLAN. That can't possibly be unless these switches cannot see each other. So Cat4, is sending BPDUs out all ports. Show spanning tree VLAN 10 in VLAN 10, but the only port in VLAN 10 is down to an access port somewhere below. It's not sending BPDUs up to switch 3 and 4 on VLAN 10 because VLAN 10 is not on your trunks. And so if you ever see that where you have multiple switches saying that they are the root for the same VLAN, I call it a dual root scenario, that just means that there's a break in the layer 2 communication somewhere. You forgot to configure a trunk, just got left off the trunk, whatever it is. So as you do your verifications, just look out for that. And if you see it, just probably means you need to go ahead and fix one of your trunks. So let's go ahead and do that. Int range gig 1021 to 22, switch port trunk, allowed VLAN, add 10. And once this starts having traffic flow, show spanning tree root port, and then it realized, okay, yep, switch 2 is the root. And that's honestly the end of just defining a root. Now, an alternate method of defining root, rather than just saying priority 0 or priority some number, hard coding a priority number, there is a macro and oftentimes people ask about it. And the macro is this. Let me switch things so I can actually show you it in practice. Spanning tree, VLAN 1 through 4094, priority. I'm going to jump the priority up to, let me get the number 16384. It's still the root, it's just not using 0. It's using a higher number. Now someone could actually sneak in down below it, right? So let's do that. There is a macro that can look at what's the current root priority. I'm going to try to undercut it. And the command is spanning tree, again, VLAN, define your VLANs that we're applying this to. Root primary. So what Cat4 is doing is it's looking at every one of these VLANs. What's the current root priority for that? I'm going to try to undercut it by at least one jump, one jump of 4096. So let's look at the running config here. What did it do? So of all the VLANs that we actually see things, it didn't all that intelligently do it. It uses the same. Since we have a lower MAC address, it should probably still work. And the other ones, it chose this other value. And so what we should see, show spanning tree root port, it took over as the root. So it has a little bit of intelligence to it to just see, okay, what's the current state of the root? I'll try to undercut it, but it's a one-time shot. So if I then came into switch 2 and said spanning tree VLAN 1 through 4094, priority 0, it's not like Cat4 is going to say, oh, someone dropped down even lower than me, I'm going to re-drop down below. You have to rerun the command to try to make it drop back down. So it's not currently monitoring the network constantly and adapting. It's just a one-time macro that runs. Yeah, it can get the job done. And so if you want to run that, I personally don't like that command because I don't like the lack of control. If some other switch had priority 0, it's not like this can undercut priority 0 anyways. And if I make changes, it's not like it adapts to those changes anyway. So I personally don't use it. It's another option. If you want to use it, great. I doubt they'll ask you to explicitly use it, but it is there just in case. All right, show spanning tree root port. And so, yep. Okay, so that's the define the root. Now this is what's typically referred to as a primary root. Almost every single time, they're going to want another switch to be the backup root. And usually what that is the other distribution switch. So one of the distribution switches will be the root, and then the other one will be the backup root. Because we never really want access layer switches to be our root switches, because it's going to negatively impact traffic flows through the network, which you'll see in the subsequent video here. So they'll say switch 2 should be the root, but if switch 2 goes away, switch 1 should take over as the root. And all that means is that switch 2 has the lowest priority, switch 1 has the next lowest priority, and then everything else is above switch 1. And so when switch 2 goes away, switch 1 will have the lowest priority of the remaining switches, and it will then become the root. But then when switch 2 comes back, it will be lower than switch 1, and it will take over again as the root when it comes back. So if they want you to configure a backup root, pretty simple. Go to Cat1, spanning tree VLAN 1 through 4094, priority, and then just choose the next number up, 4096. It's higher than switch 2, but lower than everything else. Show spanning tree root port. So it's not the root right now, but if I took Cat2 out of commission, in range gig 2, 1 through 48, just shut down every port, take 2 out of commission, what'll happen is that pretty quickly, switch 1 becomes the root switch. But when I take it back, no shut it, bring it back into service, Just give it a short little bit of time here. Show spanning tree root port. There we go. It's the root. Switch 1 is not the root, and that's the behavior that we want between when we talk about roots in backup roots. And always verify, if you either verify the functionality like I just did, make sure that, okay, if I take switch 2 out, the other switch takes over as root, or check every single device and make sure that they have higher priorities than your backup root. So just show run include span. And so I'd look for this, is there a switch spanning tree priority command? If there's not, if I go to controller 3, show spanning tree, show run include spanning tree. If there is no spanning tree priority command, which there's not, that means it's at the default of 32,678 or whatever it was, 32,000 something. And so either watch it happen or at least make sure every other switch is higher, because they can absolutely come in here and pre-configure switch controller 3 and say, you know what, spanning tree priority 4096. And so technically cat 2 takes over as the root with a priority 0, but then you might have problems on your backup root scenario. And so if you don't test it, at least verify the running config that we have the proper priority. And then always pay attention to what VLANs they're doing, because again, this is per VLAN, so either switch 2 in our case will be the root for every VLAN like we did, or they're going to divvy it up. Switch 2 is the root for the even VLANs, switch 1's the root for the odd VLANs. That's fine, just make sure you're paying attention to what they ask.